Good morning, students. I am Manikant Mishra, Modern English School, New Area. So many times we have discussed about the indicators, acid-base indicators. But today we are going to discuss about the universal indicator. What is universal indicator and why there is need to use universal indicator? First of all, I'll tell you what is universal indicator. Universal indicator is nothing but it is a mixture of two or more indicators. It is a mixture of two or more indicators. Why do we use universal indicators? Because acid-base indicator do not give us about the strength of acid or strength of the base. Only it distinguishes whether the compound is acid or base, but it doesn't tell about the strength of acid, whether it is a weak acid or a strong acid, a strong base or weak base. But this universal indicator tells us, gives information. Not only it distinguishes the type of compound, but also it helps us to know whether the compound is a strong acid or weak acid, a strong base or weak base. Like if you take a sample of a compound and you put in a universal indicator, drop a universal indicator in that solution. If it gives a red color, it means compound is a strong acid. At the same time, suppose if it gives yellow, then it is a weak acid. If it gives a light green color, then compound is a neutral, neither it is acidic nor it is a basic. If it gives a dark violet purple, then it is a strong base. So this is the use of the universal indicators. Now we have already studied about the neutralization reaction. One of the important product found during the neutralization reaction is a salt. Let us talk about first of all, importance of pH in our daily life. I forget to mention about the importance of pH in our daily life. pH change as the cause of tooth decay. As we know that the pH of our saliva ranges from 6.5 to 7.5. So basically it is a slightly basic nature. But what happens when we eat and if we do not clean it properly after eating, then some of the food material stick within the teeth. This food undergoes the degradation process, decomposition process. This carbohydrate converts with the help of bacteria, converts into acid. So it increases the acidic strength of the saliva. When the pH of saliva ranges below 5.5, then it starts to attack or starts to corrode on the thick enamel, which is made up of calcium phosphate. Though it is a very hardest substance, but yet due to increase in the acidic strength of saliva, it starts to decay. Tooth start to decay. So that's why it is a request that after each meal, clean your mouth properly and brush your teeth
twice in a day, and because that paste is a basic in nature which controls the pH of saliva. And it is also advised not to eat too much sugary substance because that undergoes the degradation process and increases the pH of our saliva. As a result, tooth decay occurs. Now, very important, since India is a land of agriculture, so very important role of pH in our agriculture purpose. By knowing the pH of the soil, then only you can decide which types of crops, which types of fertilizers you are going to add in that particular soil, which types of crops you are going to sow. So it's very important in our pH, in importance of pH in agriculture purpose. Like sometimes due to acidic rain, the soil becomes too acidic. So when the pH, we know that soil's pH is acidic, then we add calculated amount of slacked lime or lime, so that pH of that soil can be controlled. Sometimes due to acidic rain, due to industry, the water present in a water body like a pond, river, the river water becomes acidic. So due to which the survival of aquatic life also is at risk. So this pH tells us about that, how even the water body's pH can be controlled. Now in a biological process, as we know that this biological process occurs also in an ideal situation, it is slightly alkaline. Certain bacteria grow well either in a neutral medium or in a slightly alkaline medium. So by finding the pH, we can adjust the pH of that medium so that the biological process can occur effective and efficiently, like fermentation, enzyme hydrolysis. Next is also very important in a corrosion research. Like as you student, you are well aware that one of the important means of communication is water, and the present government is putting the lot of effort to enhance, to accelerate the mode of communication, water mode of communication. So now, but as we know that river water, especially the sea water, is very salty water. It corrodes very fast. So a lot of damage, lot of economical damage can take place. So before we make the ship or for mariners, we should know what is the pH of that salt water or the water. Accordingly, we can research the materials which can resist for a long. So this is a very important field for finding the pH. So with this, get it over the pH, importance of pH in our daily life. Now come to the next topic, salt. We have many times discussed salt formed as a result of when acid combined with the base, or even when metal reacts with acid or metal reacts with base, or metal bicarbonate when reacts with acid, even the salt is formed. So salt is formed due to combination of acid and base. Apart from it, as I said, acid is also formed when metal reacts with acid, metal reacts with base. Salt is also formed when metal bicarbonate reacts with acid. Now we have the different types of salt. Like what is a normal salt? Salt formed by complete replacement of H plus ion and OH minus ion. Salt formed by complete replacement of H plus ion and OH minus ion, then the salt so formed is called normal salt. So one of the example of a normal salt is Na2SO4. Here we take equal concentration and equal volume of sodium hydroxide and sulfuric acid. Equal concentration of sodium hydroxide and equal concentration of sulfuric acid. Equal volume of sodium hydroxide, equal volume of sulfuric acid. Then resulting compound so formed is called normal salt. Now another type of salt is acidic salt. Salt formed by partial replacement of H plus ion. Salt formed by partial replacement of H plus ion is called acidic salt. Like here you take sodium hydroxide, concentration is the same, but we take little excess H2SO4, as a result compound so formed as a NaHSO4. Here you see one more hydrogen is left, which can in a further reaction it can replace this H plus ion. So it is an example of a acidic salt, yet it has H plus ion, so it is called sodium hydrogen sulfate is an example of a acidic salt. Now let us come to the next step, is a basic salt. Salt formed by partial replacement of hydroxyl ion. Salt formed by the partial replacement of hydroxyl ion is called basic salt. Here we take excess calcium hydroxide and hydrochloric acid. So OH is partially replaced by HCl. So CaOH Cl plus H2O. Calcium hydroxychloride is an example of a basic salt due to presence of OH. It is an example of a basic salt. Now next next type of a salt is a mixed salt. Salt which contain more than one ion but other than H plus or OH minus ion is called mixed salt. Salt which contain more than one ion but other than H plus and OH minus is an example of a mixed salt, like a CaOCl whole Cl. Here you see Ca has 2 units of a positive charge and 2 ion is OCl minus also and Cl minus ion. So here more than one ion but other than H plus and OH minus. So it is an example of a mixed salt. Now come to the double salt. So you take equimolar ratio of aqueous saturated solution of a potassium sulfate and aluminum sulfate and followed the evaporation process. Then the resulting solution so formed is called double salt. So what is a double salt? It is a mixture of 2 or more salt. It is a mixture of 2 or more salt. It is prepared by taking saturated solution of equimolar ratio of 2 salt followed by evaporation process. The resulting salt formed is an example of a double salt, like a aqueous solution of K2SO4, H2SO4 whole thrice. Now, after following the evaporation process, we get K2SO4, Al2SO4 whole thrice 24H2O. It is called potash alum. Commonly, it is called fitcree. So, it is an example of a double salt. More salt is also an example of a double salt. Thank you. Have a nice day.